In this lesson, I'll show you 4 more examples on how to evaluate angles using the unit circle and special triangles. Question 1 reads, use the reference angle to find the exact value of sine 300. Let's start by finding the reference angle. We can do that easily by taking 360 degrees and subtracting it from 300. The reason why I chose 360 degrees is because if you plot the terminal side for this angle 300, it will be in the 4th quadrant. And if it's in the 4th quadrant, you always subtract by 360. We end up with 60 degrees. Now let's evaluate what sine at 60 degrees is in our calculator. Make sure that your calculator is in degrees when you're working with degrees. We need to go from radians to degrees, so we can do that first. Sine at 60 gives us the square root of 3 over 2. Now keep in mind the cast rule. The cast rule tells us that only cosine is positive here, all trigonometric functions are positive here, sine is positive in this quadrant, and tangent is positive in this quadrant. Since our terminal side is in the 4th quadrant, our ratio should be negative. So the answer, the exact value, is negative the square root of 3 over 2. Moving on to question number 2, they want us to use the reference angle to find the exact value of secant negative pi over 6. Now our angle here is not between 0 and 2 theta. We should make it between 0 and 2 theta for simplicity's sake. To do that, I'll find its coterminal angle by adding 2 pi to this number. I'll show you how to do it manually, although you could most likely do it on your calculator. We have negative pi over 6 plus 2 pi. If we add 2 pi to negative pi over 6, we find a common denominator, which is 6. Then we cross multiply. 6 times 2 pi is 12 pi, and 1 times negative pi is negative pi. Adding these numbers up, we end up with 11 pi over 6. 11 pi over 6, if you were to draw it as a terminal side on a polar plane, it would be somewhere in the 4th quadrant. In fact, it would be 1/12 less than a full circle. To find its reference angle, just like we did in question number 1, we're going to take 2 pi, a full circle, and subtract it from 11 pi over 6. If we do this correctly, and I'll show you manually, 6 times 2 pi is 12 pi minus 11 pi, and this leaves us with pi over 6. Now secant is a reciprocal function of cosine. In fact, secant theta is equal to 1 over cosine theta. What I can do, since my calculator does not have secant, is I can take cosine of pi over 6 and make sure that your calculator is in radians. Now it's in radians, and I'll place pi over 6 into here. This gives me the square root of 3 over 2. Because secant is a reciprocal function, I need to reciprocate this fraction. So we have 2 over the square root of 3. Now you can leave your answer like this, but some textbooks might have a different looking answer. That's because they've rationalized the denominator. They've multiplied the top and the bottom by the square root of 3, which gives you the square root of 3 at the top times 2, and then the 3 at the bottom. That's the answer to question number 2. In question number 3, they want us once again to use the reference angle. Now here we have tangent 5 pi over 4. If you locate this on a polar plane, you should find that it will be in the 3rd quadrant. Tangent is always positive in the 3rd quadrant. To find your reference angle, you take your angle, 5 pi over 4, and subtract it by the half circle, which is pi. Doing this correctly, you should end up with pi over 4. According to our special triangle, the one where we have pi over 4, and pi over 2, tangent is opposite over adjacent. The opposite here is 1 and the square root of 2. So opposite over adjacent is 1 over 1. Our exact answer here is equal to 1. I didn't use the special triangle for questions 1 and 2, but I will use it for the last question as well. They want us to find the reference angle first to find the exact angle. 405 is greater than 360, so I'll find its coterminal angle by subtracting from 360 degrees. That should give me 45. Next, I'll use special triangles, and the same special triangle as the one before. 45, 45, and 90. This is 1, 1, and the square root of 2. Cosine at 45, remember cosine is adjacent over hypotenuse. 1 over the square root of 2 would be the exact answer for question number 4. And so there you have it. That is how to evaluate angles using the unit circle and special triangles.